yesterday, I'll just finish one thing. We were getting an error yesterday in this Node.js. Let me fix that and then we'll move to our data structure. So let me go here. I'll run this npm run dev. So we have the function storage, which is used in the here in the multer call, and we are calling the single file. And once then we call this function. This is upload is a function where we pass the request, we pass the response, and this is the function which is returned. So when it gets uploaded, file gets uploaded, or if there is error, it comes in the error here, and we can track it here. So this is the main part where we have to write our logic, like responding back that it is uploaded successfully or not or something. And if error is there, we have to tell the error. So yesterday we were seeing that there was error coming here, and I will fix that error, and then we'll see more on next Saturday. Next Friday. So here, if you see, the callback always has a null initially. Callback has null, and then we have something. Here also, callback should be null and then dir. Because of that, error was coming. So this syntax is not proper. So I will fix the syntax. Before fixing the syntax, I'll show you the error. So let's see what error we are getting. So I'll try to send this one. So you will see the error is shown here. Error is some upload user one. So that means something is wrong, and we need to fix the syntax. So I fixed the syntax, and now if I try to do it, and if you see previously I was not getting any file under the user one, we should get some file. Now if I send it, you will see I have the file under the user one. Okay, now let's try to change the user two, and we will send new file here. Let's create a new file. I can upload the video also. Let's upload a video, and I will send this one. So since it's a video, it takes little time. It's done. And if you see here in the uploads, we have the user 2 folder created because I send the user 2 here, and then I have the video here. So video will not run here, but we can run in another studio or player. So the only error was yesterday that we have to pass null before the directory, and rest all is clear. So here we will write the code to the user that what is the path of this file. Because once the user has uploaded, you will see the name is changed. We are adding some sort of actual prefix before the file name. One second. Okay. So we are adding this prefix before the file name. So user will not know the exact path of the file. So once the file is uploaded, we have to send the URL information to the user that this is the path of the URL. He can access it, and that path he has to put in the database, and he can access that path with the database. So this is the information which we have to share with the user. Okay, so that's all about this one. Now we are not getting any error, and we are getting this information of the file. That is, the field name is file, original name, ME type, destination is inside this folder, and then we have the file name, and then we have the path and the size. So all this information is there, but we'll not share every information with the user. We'll only share the destination with the file name. That I'll show you how to send the information to the user so that user can access it with the URL. That we'll do on the Friday. Okay, so this is the only thing I wanted to talk about the upload part today. Now let's move to our data structure part. So last time we did the binary heap. So binary heap is the place where we know we have the max heap or the min heap, and the parent is always bigger than the child. Let's go to little diagram of binary heap again. So where we have, this is kind of the binary heap where this parent is bigger. If we are talking about the max heap, parent is bigger, let's say 14 and 11, 12. So parent is bigger than the child. That is a criteria. It's kind of the binary tree, but the difference is that in the binary tree we have the left side smaller, right side bigger. Whereas in this heap we have the parent bigger and child should be smaller. So based on this max heap, generally there is one application people used to ask in interview or in your career. I'll just let you know what it is. It is something 012. It's called the priority queue. Priority queue. So we will do the priority queue, and this priority queue is nothing but it's kind of binary heap with small differences. So like this, let's say if I have the priority of 14 and this priority should be at the top, So what is the queue exactly? Let's talk about queue. Let me come back to priority queue again, but let's talk about the queue. Queue is first in, first out. So if I have this queue, person A comes here, then B comes, then C comes, then D comes, then E comes. So person A will go out first, then B will go, then C will go, then D will go, then E will go. Okay. Now what is the priority queue? Let's talk about the priority queue. So we will use a binary heap to implement the priority queue. So in interview, they will ask you, how will you implement the priority queue? So for that, you can use linked list, you can use array, but the main thing is you should follow the binary heap to implement the priority queue, because this is the optimum solution for the priority queue. Okay, so what is the priority queue? Let's say a person comes and it has the priority of 1. Then B person comes, he has the priority of 2. Since the B has the more priority, so A will not go out first, because though A has come first, but B has greater priority than A. So B will be shifted to A place and A will be here. Now, though A came first in the line, but because the priority is less, so he will be pushed to the back, and B has more priority, so he will be in the top list and he will go first out. Let's say C comes in the picture and C has a priority of 10. So now B will also not go first, C will go first because C has the bigger priority. So though it is a queue, but the queue is based on the priority. It is not based on who comes first, but based on the who has the highest priority. But if D comes with a priority of 1, so D may be in the list of A. It can be, it doesn't matter, it goes A, exactly A first or D first, but all with greater priority will be at the highest level at the beginning. So that is about the priority queue. This is generally seen in the hospitals where person with the serious problem, though people who have come with the less serious problem, they have to wait till the doctor check the serious person first. So let's say a patient 1, he has headache, he will be in the line. If no person is coming, doctor will check him and he will go out. But before doctor takes him, another person is coming with the head injury. Head injury is very serious comparative to headache. So this person will be before the P1. This P2 will be before the P1 because he has a head injury. Head injury has priority of 10, for example. So he will be before the P1. So this, though it is a queue, but it is based on the priority. So we have to implement priority queue based on the binary heap. So now this is the idea. Any doubts in idea? Okay, so you got the idea that we have to do the queue, but it is based on the priority. So let's try to implement that in our use case. Okay, let's try to write the code and then we will see how to use it. I'll write the code first here in the console and then we'll go there. Since, if I was doing the binary heap, we were only having, let's open the binary heap. So in the binary heap, we were only having the numbers here, you see, number, because we were only storing the number, nothing else. But here, in this case, in the priority queue, we need this number, and we also need the priority. What is the priority for that number? So the number doesn't matter, but the priority matters in this. So the whole chain of the binary heap will be based on the priority and not the number which we are getting it. So let's try to write down the first function node. Like we were doing in the linked list, we will be doing here also node. Node has some value and it has a priority. So value is only for the reference. Maybe I can say value maybe patient name, or I can say it can be a data, patient name, age, gender, anything. So value can be anything. You can pass anything about the patient. But the priority, when doctor should check that person, that is the priority. So if the priority is more, doctor will check it first. And if the priority is less, doctor will check him later. So that is the idea of here. So here I will write down. Value can be anything. Maybe patient name or details. And priority is a number or integer, is an integer which will be used in priority queue or used when doctor should check that person. If priority is high, then it has higher priority and doctor will, I am considering the hospital case, but we can relate to anything, anywhere. Okay, so that is the idea. Now this is the node as we did in the linked list. Here I will say this dot wall equal to wall, and I'll say this dot priority is equal to priority. Okay, so this is the first function I have created. Everyone should write down this function before we go further. I'll give you 2 minutes to write down this one. Okay, so it's done as per Anand. I will create a file here, priority queue.js, and I'll create first function here. Okay, so this function is done. Now, next one is, after we are done with this node, we will create our priority queue class. So I'll say function priority queue, and in this function, I will write down the code which I want to implement for the priority queue. So if you see the binary heap, it has the values. So everything will be stored in values as in the max binary heap. So I'll copy this max value, max one here. So I'll say this dot values is empty. So initially, no one is in the priority queue. Okay, and as soon as the patient will come, we will update these values. And previously, if you see in this binary heap, all values were like this simple number, but now it will be the node. And value can be anything, patient name or details. But in this case, in this example, I will take the disease name, what he is suffering from, so that we know if it's a small problem, priority should be less. If it is a bigger problem, priority should be higher. So in my example, value will be the disease name now, but we can put anything in the value. Okay, so the first step is put the priority queue this value. Just put this one and we'll go further. 1 minute to write on this one. You can also write down a notepad or in the console, and then you can save it somewhere, wherever you want. Okay, so now this is a priority queue which will implement this my project which I told doctor should check doctor will check which person first. So since this function is here, I will call this class and do something. So let's say I will say var priority queue is equal to new priority queue. So I'm calling this priority queue here with this variable. So this is the new object, and then we will write more things inside it based on our use cases. So what things we should put inside this function? So let's think about this. When the patient comes in the hospital, he wants to enter into the queue. So that is called insertion. Maybe in the binary we saw the insertion, but here we will name the insertion is NQ. NQ means we are entering the patient inside our hospital. That is insert. So I will create first function called as this.NQ is equal to a function which I will fill in few minutes. So what will happen when a new patient will come? I want to tell what kind of value this patient has, and I will also send the priority for this patient. So value can be anything as I said. And the priority, you have to tell what is the priority, because you know when the patient will come in the hospital, the nurse will check and she will see if the patient is very serious or not. If he is very serious, she will mark priority as more, 100, 200. And if she sees the patient has minor problem, then she will put the priority list. The next function which I want to do in this case is remove the patient from the list. That is, once he has checked by the doctor, we don't want him in the priority in the queue. So we will name it as DQ. DQ means removal of the patient from the queue. If we don't remove it, how the another patient will come? So we need to DQ. And DQ will not take anything. It will just a function. So just write down this lines and we'll go further. 1 minute to do this one. Okay, so let's try to put few examples before we really write a code for this one. So let me put few values. Let's say patient first comes in the hospital. I will say PQ dot NQ. So patient has common cold. Let's say patient has common cold. And the priority, we can mark it as, for example, 10. You can mark anything. Then another patient comes in the hospital. He has a problem of, let's say, gunshot. He got the gunshot wound. So this is a very high priority. So it should be checked first before common cold. So let's put the priority of 100. Then next is the PQ dot NQ. Next patient comes with a high fever. So this high fever should be greater priority than common cold. So let's make this as 30 as a priority. Okay, after I add 3, I want to see what is the values in the priority queue. So let's write console.log pq.values. Okay, we want to see what the values are. Okay, so these are the examples I want to put before we go and write anything inside it. So let's go to console again now. I will add these few things. Okay, so first we are entering the patient in the hospital. That is, we have to take care of this NQ part. Okay, so what is the first step in the NQ? What should we do? So previously, if we see the binary heap, we were taking directly the value and putting inside the values. So idea here is in the binary max heap or in the priority queue, idea is this is the values array. Whenever any value comes or whenever any part we want to insert it, we just add it here inside this array. For example, if I add 10, I will add it here. Then if someone puts 20, so I will add 20 here. First I will put in the end, and then I will move this to proper place wherever it should want to go. So that is the idea we have to implement here in this one. So first thing is we need to, previously in the binary heap we were just putting the value, but here we have to create the node for each one because we have to set the priority also. So we have to put a node also for each patient. So let's create the node for this one. I will say constant new node equal to new node. Since this is a class, so I have to say new node. It's not a normal function. And I will pass the value and priority in this one new node. So new node is consist of value and priority, which will be kind of a node which we have, and we have to put this node in the values. So how to put it? I will say just this dot values. First step is just put it in the end and then rearrange it. This dot value dot push new node. If I don't rearrange, whatever I will try to push will be one behind the other. It will be the normal queue. It will not be the priority queue. Priority queue means whenever I try to add something, it should be added in the end and then it should move to the proper place. So that based on the priority, we should move him to the proper place. So just write down these 2 lines and I will run this without rearranging it to see what happens. So let me run it. So once I run it, you will see 3 nodes are there. First is common cold, second is gunshot, third is high fever. So here, whatever I added it, it is added as it is. It is not moving it to a different position. We should check the gunshot person first. So gunshot should be at the top level, not at the second level. So that is what we have to do it. Now, after adding this value, we have to rearrange the last value to its proper position. So just put this 2 lines of the code and then we'll go further. So just add these 2 lines of the code. Yes. Now we will, whatever the movement will happen, it will not based on this value. Value can be anything. It will be based on the priority. Whereas when we were doing the max heap, we were only putting simple value and we were moving based on that value. But now everything will be same, but the criteria to move is this priority. Okay, so let's go further now. So what we did, whenever any node is there or any value is there, we will just put in the end of the values. And then based on the logic, we will move that to the different position where it should actually lie. So now the next part is we have to rearrange this new node at the proper place. Okay, so let's do that here again. Okay, so here I will write down now more code. Right. Before that, I will just put some comments. Create a new node based on value and priority. Just put the new node at the end of the values and then rearrange the node at proper position. Okay, so this is, let me copy these two lines. Okay, I'll be back in 1 minute. Yeah, 1 minute. Give me 1 minute. I have to just do one thing. Okay, I'll be back in 1 minute. Just to have one work. Okay, so let's continue. So we have to put this new node at the end of the array. So we are pushing it, and now we have to rearrange this new node at the proper position. So let's write down the logic of rearranging. Okay, let's go here. One second. Okay, let's write down the logic of rearranging. Okay, now rearrange the new node at proper position. Okay, that is what we are trying to do it now. Okay, so to rearrange, okay, we will first we'll check the index of this new node. That is it has been added and the end of the values. So first we have to write down the index of the new node. Find the index of the new node. So what is the index of the new node? Can anyone tell me? Let index is equal to what? Just type it. What should be the index? Since this is added in the values, I want to access. So for example, I have the array. Okay, array is here. So I'm adding one object with value X, priority 1, anything, whatever I want. and then I add another object. When I add another object, this is the having the index of 0. When I add another object, this is the index of 1. So how to calculate this index, the last index which I have added it? So what is the, I cannot put 0 because this is the index, new node which I added. It cannot be 0. This is the last node we are talking about. So for example, this one I added last. It is the value of y, priority of 2, for example. So I want to know the index of this last element which I inserted, length minus 1. So whenever we want to take the index of the last element in the array, it is always the length minus 1. So I will say here, so I will write down here, the index is this dot values dot length minus 1. So we have to figure out the index of this element, the last element which we have. Okay, so let me delete this one. Let's comment this one. Okay, so we got the index of this element, the one which we want. Though we know it is new node, but let's try to make it in another variable, because sometimes this part goes in another function and this part goes in another function. Though I'm putting it in single function, but sometimes people don't want to make too complex, so they put this part in one function and this part in another function. So to get this new node, we will write down a new variable. So let's say new variable to know the last element added. So we know that last element is new node, but if we want to find the last element from the values, how will I find it? I will say constant element is equal to this dot values, and I will say idx. I will put the idx. Okay, so this, if it is 1, this is 1. I will say this dot values of 1. I will get this last element, and I will put it inside this element. Why I'm writing this extra step, though I know it is a new node, but sometimes we want to put it in another function, so we should be able to get the value or this element from this values array. So we are just writing an extra step in case we want to move it to another function. Now we know this element and we know the index. Okay, we know the index and we know the element. Now we have to move it to the proper position. So to move it, we don't know how many elements are there and where should be the position of this one now, because we just know this is the value we got it. But since we have to move it top, we will write down the while loop and it should go on doing it till we get the till we reach the proper position. So since we have to move it up, I will say loop through so that element should reach at proper position. And what is the proper position? Proper position is something when index should be greater than 0. Okay, that is the condition, because first one is 0, index should be greater than 0. Till then we will be looping through and move to the up and up. We will go up and up. So I will say while index should be greater than 0. If it is 0, then we don't need to move. That means this is at proper position. Because if it is at 0, then that means index is at 0, then we don't need to move it. So the condition is index should be greater than 0. If this index of this element is greater than 0, then only we have to loop it. Otherwise, no need to loop it. Okay, before I go further, just write down these two parts and we'll go further now after this. I'll give you 1 minute to write on this one. Okay. So now what happened here is we know this, we are adding this one, and then now we have to move this value, this last position at the proper place. Okay, so how to move it? So first what we have to do, we have to take the parent of this one. What we have to do? We have to take the parent of this one. So here I will write down, because we have to go parent and parent and parent and parent. Find the parent and parent's index. This is the task. So if I write down here, let's say I will say constant parent index IDX equal to something. I need to find it. And then I have to say constant parent equal to something. So this is the example which we are doing. We are at the second level. Now we have to find the parent index and the parent value. That means parent index is, the parent value is this one and index is this one. This has the index of 1. This has the index of the 0. So we need to find the parent index, that is 0, and the parent value, that is this value. We need to find two things. So how will you find the parent index? What is the formula to use the parent index? Can anyone tell me how to find the parent index? What is the formula to find the parent index? What is the formula to find the parent index? Right now we have two values, but it can be 1000, 2000 values. And with which formula I will know that which is the parent of this node? What is the formula? Anyone, just think, what is the formula to find the parent index? So I have this one. I will say it has priority of 1, and then I added this is the priority of 2. This is with the 0 index. This is the array which we got. This is the 0 index. This is the 1 index. So for 1 index, I want the parent. What is the formula to get the parent? So to get the formula to find the parent, formula is math.load. We have to use floor, and inside floor we have to say index idx minus 1 divided by 2. So if index is 1, 1 minus 1 divided by 2. So it will be 0 divided by 2. So it says 0. So the parent of 1 is 0. What is, let's say if I reach here, it has 2 index. Then I go here, it has 3 index. What is the parent of this? Can anyone do based on this formula? What is the parent of this? Ola cannot hear me. Anyone else who cannot hear me? Okay, maybe he has some problem in his mic. Okay, so can anyone tell me what is the parent of this one? Now 0.5. You have to use this formula. Using this formula, how you will get 0.5? Why 2? Why 2? This is 2. Do you think this is 2? We have to check the index minus 1. What is the index? What is the index? 0, 1, 2, 3. If I am at the 3 position, why you are taking 2? So what should be the parent of this one? 3 minus 1 upon 2. That means 1. So parent of 3 is 1. What is the parent of this one? This is 4. Based on this formula. What is the parent of this one? 4 minus 1 upon 2. That means 4 minus 1 upon 2. That is 3 upon 2. That means 1.5. 1.5. If I want to take the floor of 1.5, it is 1. So that means the parent of 4 is also 1, not 2. 3 upon 2 is 1.5. 1.5, we have to take floor. Floor means we have to take 1, not 2. So the parent of 4 is also 1. So based on this formula, we have to find the parent in our use case. Okay, so let's do it. So we have parent index. So parent index will be math.floor, and inside math.floor I will say index minus 1 divided by 2. So this is the formula to get the parent index. Once we get the parent index, so the parent index of this one is nothing but this one, that is 0 number. Once we get the parent index 0 number, I can take the parent value. How will I take the parent value? What should I write to get the parent value? What should I write to get the parent value? I got the index 0. Now I want this value, this node. I want this node as a parent node. What should I write here to get this node? Not 0. You cannot hard code 0 value. You have to be dynamic. Here we have 2 elements, so you are saying 0. But you cannot put 0. I cannot say 0. 0 will not be right in all cases. So you tell me, what should I write it as a dynamic value? The 0 is wrong. I cannot put hard coded 0 value. I have to put some variable name. To get this one, what should I write here? Right. This dot value dot parent index. So we have to take the parent index. Okay, so we got this as a current node and this as a parent node. Now we have to check if this has the higher priority or this has the higher priority. If tomorrow if I write down this as a 2 and this as a 1, then this has the low priority and this has the high priority. If I write on this as a 1 and this as a 2, then this has a higher priority. Let's try to do this. Let's try to do the reverse case first. Let's put here as a 100 priority and let's put here as a 10 priority. Since this is a 10 priority, so which one has the bigger priority? First one, the 0 position or the first position? 101. So this one has a higher priority. So do you think we should swap this to this position in this case? No. Anand is saying no. That's correct. We should not swap because the higher priority will remain at the top position and the lower priority will remain at the bottom position, that is this one. So if this is the case, then we should not swap it and we are done with the swapping logic. So here what I will say, I will check something, and if that condition is made, I will break. I don't want to go further. Now what should I put inside this if condition? So what you're trying to is check priority of this with the priority of this. So can anyone tell me what should I write in the if condition? So that it should break and I should not go further. What should I write here so that the priority of this is greater than this? So I should parent index greater than parent. Okay, first when you are checking this condition, I want exact condition. I don't want you to give me partial answer, because whatever you will give me, I will think it as a final answer. So you cannot check parent index with the parent. Everything which you have to check is this, and this is nothing but this element, and you have to compare it with this one. This is the parent. So you cannot check parent index with the parent because both are same and both are the one and the same thing. This is only the index and this is the parent. So I will not accept if you are comparing this with this one. All the comparison should be with the element. This is the element and this is the parent. So what should I put it here? Parent index greater than element. See, parent index is 0. You cannot compare index with the element. Element is this object and index is 0. You have to specifically tell me exact if condition. You cannot say parent index. Parent index is always 0 in this case. And this element is object. How are you comparing index with the element? So tell me is correct if condition. Parent index is the index. So the value of this is 0. And this is the value of this is 1 in this case. This one. Element is nothing but this one. Okay. And this parent is nothing but this one. I want everyone to answer. Only Anand is answering. Try, you should try. Now what should be the if condition? I want to check this 100 with 10. And what should I say that it should break? So this priority should be greater than this priority. Then it should break, because if this priority is greater, then we don't need to swap. We don't need to go further. We are at the correct position. if values, see, values is done. We are not checking the values. We already took the values and put it in this variable and this variable. So now don't put values in this if condition. This if condition should have only element and the parent. Okay, so no need to go to the values part now. We already took the values and put it in some different variable. Now the comparison should be between this line and this line. Everyone has to answer. Just write down whatever wrong or just try. I want an answer from everyone. Parent is this object. Parent is this object. Element is this object. One object cannot be greater than another object. You cannot compare object is greater than the. So if you write parent greater than the element, you are comparing object. How will you know which object is greater? Parent index is some index 0. It does not have priority. So you cannot say parent index dot priority greater than element dot priority. So you have to compare with this line with this line. So what will be the exact if condition? I want answer from everyone, even if it's wrong. Because if you are putting wrong, I will understand that it is wrong and I will correct you. So we have this parent which has the value of x, priority of 100, and then we have this element which has the value of y, priority is 10. Element dot priority is greater than parent dot priority. So if this is greater than, so you're saying, Anand, you're saying element dot priority greater than parent dot priority. If element is greater than priority, then you are breaking, then it's a wrong, reverse. Yeah, it should be reverse. I want answer from everyone. Okay, any other answer? Anand has given. I want answer from every one of you. What should you put in the if condition? Okay, so I think no one knows the answer. So what we have to check? We have to check this priority with this priority. And if this priority is greater, then we have to break it. And what is this priority? This priority is a parent priority. Parent index is the index of this one, parent's index. Okay, this is the index 0 number. So to check here, I will say parent dot priority. So this is the parent dot priority. Yeah, we have saved this value in the parent. So I'll check if parent dot priority is greater than element dot priority. Okay, I'm not sure, Anand, what you are trying to ask. Parent dot priority, that is this one.
Yes, sir. I'm saying we have taken the index of parent index, and we are saving parent index value in parent so that we can compare with the element.
Right. We have to compare parent with the element.
Yes, sir.
Yeah, right. So I have to check. I have to check parent dot priority. If parent dot priority is greater than element dot priority, that is this one, then it means we are at the correct position. Parent should be greater than that. So if parent dot priority is greater than the element dot priority, then we don't need to swap it. We are at the correct position. So we will break if parent dot priority is greater than the element dot priority. But what if parent dot priority is less than the element dot priority? That means in this case we need to swap it. So now here we will write the swap logic. And here I will say if parent's priority is greater, then do nothing. Come out of the loop. Okay, so if parent's priority is greater, that means it is at correct position. We don't need to do anything. But if parent priority is less, like in this case, then we have to write down the swap logic. So let's write down the swap logic. So what is the swap logic? I will say, so what we have to do at the 0th position, I have to put this one. So first I will write down hard-coded value and then I will change it. And at the 1 number position, I want this value. Okay, at 0 number, that is the 0 number, I want this value. And at the 1 number, I want this value. So I will first say this dot values. So at 0 number, I want this one. This is nothing but the element. So at 0 number, I want element. And at the 1 number, I am putting hardcode values, but I will replace it with the dynamic value in a minute. At 1 number, I want this value. What is this one? What is the variable for this one? Parent. This is called parent. So at the 0 number, I want this child, and at the 1 number, I want this parent. So at 1 number, I will put parent. Okay, so I put hardcode value. And once I change this, once I change the position, I will also change the index. So initially the index was this one. Now the index will move to this one. So index will move from this to this. That is from 1 to 0. So what I will say, index equal to 0 is nothing but it should be 0 now. Initially it was 1. Okay, so index was here as we said here, this line. Index was 1. But since this one is moved to this position, so we need to move index also to this position. Wherever this element will go, index will follow with that element. Since index is moved, this element has moved to this position, so the index will also move to this position. Now this is the hard-coded value. Now we have to replace it with the dynamic value. What should I replace with 0? What do you think? What is 0 in this variable? In all the variable which we have created, which one has the 0? Parent index. So parent index is 0. So we will replace 0 with the parent index. And what should I replace with this 1? What should I put instead of 1? So we have to put this parent part, this parent, to here. So 1, I will put 1 with what? What is the 1 in this whole variable? So 1 is this index. So values of index will be the parent. So what we are doing? Parent index, that is this parent index, is getting this value, and index, which is this index, will get the parent value, that is this one. So we are swapping this with this. Okay, and then we are updating the index with the parent index, because index should be updated. Index will go with the element. If element is updated, index will also update. And it will go again. It will check if index is greater than 0. But in this case, index is 0. So we don't need to go inside the while loop. And we'll come out of the while loop. And once we come out of the while loop, this value is updated with the correct value. Okay, so let me write on this one. And okay, let's run this one and see how it goes. So I will give you 2 minutes to you to finish this part. So complete this while loop. I will give you 2 minutes to complete this while loop. Then we'll go further. Okay, let's run this and see how it goes now. If I enter it, you will see the gunshot has gone to 100. Common code is, yeah. So in this priority queue, so the main, okay, so this 30 is not going correctly, right? 30 should go. Okay, so the thing is that it has the two level. The priority queue doesn't care about the levels kind of thing. So level part should be remain same. So as we see in the priority queue, so if it is 100 and this one is for example 10 and this one is 30, so they don't swap. These siblings don't swap. Okay, though it has the 30, it will not swap with the 10. But when the 100 will go out, then 30 will come to the top. So at the correct current position, though 100 is at the top, 10 is second, 30 is third, the siblings will not swap with each other. But when the 100 will go out of the loop, then 30 will move to the top level and 10 will remain as it is. So here you see the gunshot is at the top level and these two are the child, these two are the sibling level. So though 30 is having the higher priority, it is still at the last level. But as soon as we remove the gunshot, this high fever will go at the top level and common cold will be below it. Okay, so that's how the priority queue works, or that's how the binary heaps work, and the priority queue also work this way. Is that clear, this part? So let's recap what we did. We created a new node. We pushed the new node in the values array. Initially, we push in the values array at the end, and then we rearrange. How we arrange? How we rearrange? We take first the index of the element which is added, that is the last value. We take the element which is added, that is the last value. Then we loop through till the index is greater than 0. For each case, we compare this element with its parent. If parent priority is greater, then that means we reached at the correct, we break it. But if the parent's priority is less than the current priority, then we swap. We change the element to the parent position and we change the parent to the element position and we change the index to the parent index because this element goes always with the index. So index will also change it based on the change logic. And after this, once we are at the correct spot, we come out of the loop and we are out of the loop. Same thing is happening here. So though gunshot is at the top, other two doesn't care. We don't care if 30 is here or 30 is here because sibling doesn't matter. But once this is deleted or gunshot is treated, then they will check the priority again and they will take the 30 number priority. And so high fever will move at the top once the gunshot is gone. Is that clear? So what we did here? We only checked how to insert it. Okay. Once the gunshot is done, we have to remove the gunshot. And once we remove the gunshot, we want a new priority, good priority, to replace it with the gunshot. So that is called the removal part, which we will see next Saturday. So today we have just seen how to add in the priority queue. Next time we'll see how to remove it. So once I remove the gunshot, how the other things will move. That's what we'll do next Sunday. Any questions?